In the last video, we derived the 6 trigonometric ratios for a 45-degree angle. So this time, we shall do it for a 60-degree angle. So this is what we shall do. We shall construct a right triangle and then use SOHCAHTOA to produce the sine of 60 degrees, cosine of 60 degrees, and tangent of 60 degrees. So let's say, for example, we have an equilateral triangle. So an equilateral triangle has congruent sides. Let us call the sides side A. And you know what? Equilateral triangles are also equiangular. And the only distribution of angles for an equiangular triangle is each of the interior angle is going to be a 60-degree angle. Okay, so this one is congruent to angle alpha, and this one is also congruent to angle alpha. So all in all, this is 180 degrees. That is the sum of the interior angles of any triangle. Now I will draw a line CD that bisects angle C. And of course, you know what the angle measure would be. It will be 30 degrees, and this one is also 30 degrees. So CD is an angle bisector. And one of the property of an equilateral triangle is line CD is perpendicular to the opposite side. And not only that, it's going to be a perpendicular bisector of the line AB. So this means AD. So this means AD is equal to 1/2 of A, and DB is equal to 1/2 of A. So our right triangle now is the triangle ADC. So triangle ADC is a right triangle. We are almost there. But in order to produce the ratios of the sides, we need a measure. What is the measure of the line CD? CD is one leg of your right triangle. So using your Pythagorean formula, it's equal to the square root of A squared minus the square of 1/2 of A. And it's equal actually to square root of 3/2 times A. That is the length of side CD. So we are now prepared to produce the trigonometric ratios corresponding to a 60-degree angle. And we shall need your SOHCAHTOA to produce those ratios. S stands for sine, C for cosine, and T for tangent. So sine of 60 degrees is equal to the side opposite square root of 3/2 times A divided by the hypotenuse. A divided by A is 1, and so we are left with square root of 3/2. That is for sine of 60 degrees. What about cosine of 60 degrees? Ka, side adjacent to our angle. This one, that's 1/2 of A divided by the hypotenuse. So cosine of 60 degrees is 1/2 of A over A. A divided by A is 1. We are left with 1/2. What about tangent of 60 degrees? So tangent of 60 degrees is TOA. Look at that. That's TOA. It's equal to square root of 3. Now, there is another set of trigonometric ratios. These are the reciprocals of sine, cosine, and tangent functions. So for sine, the reciprocal of sine is cosecant. Okay, so how did cosecant of 60 degrees become 2 times the square root of 3 over 3? Okay, so let us show it. So we will rationalize the denominator, and we will do it by multiplying square root of 3 over square root of 3. So that is cosecant of 60 degrees. The reciprocal of cosine is secant, and obviously the reciprocal of cosine of 60 degrees is 2. So secant of 60 degrees is 2. What about tangent? What is the reciprocal of tangent? It's cotangent. 1 over square root of 3. And of course, you know what will happen. We shall rationalize the denominator. Okay, and so this becomes square root of 3 over 3.